everyone. Welcome to another episode of the show about science. This is your host, Snape. And this intro is going to be a bit smaller than usual because today we're talking about nanotechnology. What's that? Well, let's meet today's guest and find out. So, hi.
Hello.
Could you tell our listeners a little bit about yourself?
Sure. My name is Mark Hersam. I'm a professor of material science and engineering at Northwestern University. My research is in the area of nanoelectronic materials. I've been at Northwestern for almost 19 years. And before that, I was a PhD student at University of Illinois, Urbana-Champaign. I also worked at IBM T.J. Watson Research Center before joining Northwestern.
So I'm really excited to have you here in the Show About Science studio to talk about nanotechnology. So, how did you get interested in all of this?
Yeah, when I was in college, as an undergraduate, I had a professor, Professor Joe Lighting, and he introduced me to the scanning tunneling microscope. The scanning tunneling microscope is the world's highest resolution microscope, and it allows you to image atoms. But what's even more amazing about this microscope is it allows you to manipulate atoms. You can move atoms around into patterns, which to me was remarkable because when I was a kid, you hear about atoms in class, you look at textbooks where you learn about atoms, but they're always cartoons. You never get to see the atoms. And this microscope allows you to see them, to move them around.
All right, quick question.
Yep.
What does an atom look like?
Yeah, that's a good question. So in the scanning tunneling microscope, it really just looks almost like a small ball. But the geometry or the spacing and arrangement of the atoms varies from material to material. And so, this ability to sort of manipulate materials at that length scale is extremely enabling for almost any technology. So what was sort of remarkable to me is electronics have always been driven by miniaturization. And that's why, your phone gets increasingly powerful with time because you make the devices smaller and smaller. And this microscope allowed us to look into the future of electronics.
So let's talk a little bit about nanotechnology. Where should we start?
Yeah, we should probably start by talking about the prefix nano. What does that mean?
I think it means small.
It is small, agreed.
Okay.
So it's a prefix that means 1 billionth, and it's referring to a nanometer, which is 1 billionth of a meter. To put that in some context, strand of hair is about 100,000 nanometers. So a nanometer is 100,000 times smaller than a strand of hair. Very small, about the size of a DNA molecule.
I see. So when doing research for this episode, I heard a lot about graphene and graphite. Can you talk about those and maybe how they're related?
Right. So graphite is a material you probably worked with before. It's pencil lead.
Yeah.
And one thing you know about graphite is that it rubs off very easily. And that rubbing off of graphite is how you produce graphene. Graphene is one atom thick sheet of graphite.
So, if it's one atom thick, how can you see it?
Yeah, it would be difficult to see with your naked eye, but you can use high-resolution microscopes, and that allows you to observe graphene.
So, how does graphene work, and how can it be, so strong?
Yeah, so graphene has very strong chemical bonding in plane, sort of parallel to its surface, but very weak bonding out of plane. And that's why graphene can be slid off from graphite because it's very weak bonding between the layers. But within the layers, the bonding is exceptionally strong, and that in part leads to its mechanical strength.
So, let me get this straight. If you go to the side, that bonding is, really strong, some of the strongest in the world. But if you go up and down, it's, pretty weak bonding.
You got it. Absolutely.
All right.
And this allows you to peel away the layers relatively easily, and that's how we get down to graphene from graphite.
What would it take to pierce the really strong bonding of graphene?
Yeah, so the analogy which is often given is if you had a very sharp tip, like a needle, and you had an elephant balancing on top of it, that amount of pressure is the amount required to penetrate through graphene.
You mean a plastic elephant, right?
No, like a real elephant. That's how strong graphene is.
Okay.
Amazing, right?
Yeah, definitely. It's like a super material.
Absolutely.
So what are some uses for graphene?
Yeah, so one thing that's interesting about graphene is that it's very inert chemically. By that I mean you can put it in very harsh conditions and it won't decompose. And one place where that's important in everyday life is inside of a battery. Inside batteries, we have very caustic, very acidic environments, and graphene is very stable under those conditions. So we actually use graphene as part of the electrodes in batteries.
So, how do you make graphene?
Yeah, there's a few ways to getting there. The easiest one to understand is starting with graphite. If I had some way of peeling it away down to 1 atom thick, I would get graphene. The first time it was ever done, it was done with scotch tape. They took a piece of scotch tape and literally peeled off a layer. And the scientists who did that won the Nobel Prize in physics because they were the first to isolate graphene. Very simple, but in a more scalable manner, we can do this in solution. We put graphite into appropriate liquid. Yeah.
Was it let's just put a piece of scotch tape on this? We did it!
Amazing, isn't it?
Yeah. How something so simple can be the actual right way.
Yeah, it's amazing. They basically took pencil lead and scotch tape and won the Nobel Prize.
So, what exactly are carbon nanotubes?
Yeah, so carbon nanotubes are one example of nanomaterial that's used in electronics. Specifically, it's a cylindrical or tubular form of carbon that's about 1 nanometer in diameter and can be hundreds of nanometers in length.
What could they be used for?
So there's many uses for them. The one that we focus on is electronics. And one thing that's happened in electronics over the past few decades is that the individual devices in the integrated circuit have gotten smaller and smaller and are now approaching the nanometer scale. So a carbon nanotube is ideal because it's already at that length scale.
So, I'm just going to propose an idea, put it out there for a different kind of nanotube. What if you took some graphene and rolled it up to make a graphene nanotube?
Yeah, so you actually are pretty darn close to reality. The structure, the bonding on the surface of a carbon nanotube is the same as that in graphene. And so if you did have a means of cutting out a rectangle from graphene and you could roll it up, you would get a carbon nanotube.
Wow. So basically a carbon nanotube is graphene rolled up. So is it about the same thickness as graphene or a different thickness?
Yeah, so if you think of the carbon nanotube as a cylinder, it's hollow, and the surface of that cylinder is graphene.
So what if you took some graphite and then put in the middle of a carbon nanotube, would you not graphite, graphene, would you just get graphite all over again?
If you could take graphene and stack it up, then you could return to graphite, as long as the layers are aligned.
Do you know of any other sort of nanoparticles?
Yeah, there are many, many nanoparticles. Almost every element in the periodic table and combinations of them exist in nanometer scale form. Some are particles more like balls. Some are tubes, like the carbon nanotube. Some are sheets, like graphene. And so there's almost endless possibilities.
If kids are interested in nanotechnology, how can they learn more?
There's a number of resources out there. So at Northwestern University, we have a Nanotechnology Institute, and that institute has online resources and a lot of opportunities on campus to come learn more about nanotechnology.
Thank you for being on the show.
My pleasure. Thank you for having me.
There you have it, folks. The show about science is complete. Our theme song was written by Jeff, Dan, and Teresa Brooks. Okay, Dad, you can shut the recording off. Hi, everyone. Before you go, one teeny tiny nano, you could say, request. If you're a fan of the show, please leave a review at Apple Podcasts or wherever you listen to the show about science. Thanks.